Okay, so let's start off with example number 2 now. For this example, it says for the following logarithmic function, g of x equals to negative log 2x plus 2 minus 5, describe the transformation that must be applied to our base function y equals to log 10, so log base 10x to obtain the graph of g of x. So just before I start off over here, I am going to factor out the 2 to be able to classify what each one of my parameters are. So for the first case, g of x is equal to negative log, factor out the 2, x plus 1 minus 5. And then I'm going to basically just allocate what each one of those parameters mean. The negative sign right here means there's a reflection in the x-axis. That's the first thing. Reflection in x-axis. The 2 right here means this is a horizontal compression by a factor of a half. And then just moving forward, this d value is negative 1, so that means there's a horizontal shift of 1 unit towards the left-hand side. And whenever I'm writing my horizontal shifts, I always like to write down on the side what my vertical asymptote is. Just helps me keep in mind what my vertical asymptotes are when I'm graphing the function. So in this case, the vertical asymptote is going to be x equals to the d value, which is equal to negative 1. Okay, moving on, I also have a vertical shift of 5 units downwards. Okay, great. So that basically concludes part A, where I've described the transformations. Part B says sketch the graph of g of x. So when I'm sketching it, I'm going to allocate what my key points are, as well as my transformed key points, along with my vertical asymptote. Okay, so let's go ahead and do that. So my key points, x, y equals to log base 10x, and then my transformed key point, which are going to have my transformations on there. The a and the c value affects my y axis, so this is going to be a negative y minus 5, and then the x value is going to be affected by a horizontal compression as well as a horizontal shift, so that's going to be x divided by 2 minus 1. Okay, and my key points always start off with 0 and 1. Writing my logarithmic into an exponential function would be 10 to the power y equals to x, and I'm going to be using this part to be able to classify what my x is. So my y value here is 0, so I'm going to plug in 10 to the power of 0. So I'm just going to right there, 10 to the power of 0, and that's going to give me my x value, which is 1. And 10 to the power of 1 is going to be 10. Okay, so now that I have classified what my x and y values are, I'm just going to transform them over here. So it's 1 divided by 2, which is a half, minus 1 is negative a half, and then 10 divided by 2 is 5, minus 1 is 4. Okay, doing the exact same thing with a y coordinate. 0 times negative 1 is 0, minus 5 is negative 5, and I have 1 times negative 1 minus 5 is a negative 6. Classifying my vertical asymptote is x is equal to negative 1. I am going to now sketch my curve. I am towards the negative side here. So negative 1, negative 2, negative 3, and my y values are also towards the negative side. So it's negative 1, negative 2, negative 3, negative 4, negative 5, as well as negative 6. X-axis, y-axis. I'm going to start off by just plotting what my vertical asymptote is first. So x is equal to negative 1 is my vertical asymptote. Plotting my key points, negative a half and negative 5. So negative a half and negative 5. And then I have 4 and negative 6. 1, 2, 3, 4, and negative 6. That is right there. Okay, now I'm just going to join those points and make the curve approach x is equal to -1 my vertical asymptote. It's a little curvy though. And I'm just going to draw arrows that it continues. And I'm just going to label this function as g of x equals to negative log 2x plus 1 minus 5. Alright, great. So that basically concludes part B. Part C says, just going back to part C here, state the equation of the vertical asymptote. We already did that in part A as well as in part B, and we're just going to formally write it down now, which is x is equal to -1. Part D asks to write down the domain and range of the function. So when I'm writing down the domain and range, I'm going to refer to my graph. The domain here, the function is basically only defined when x is greater than -1. So writing that in set notation, x such that x is greater than -1, x is an element of all real numbers. My range here, there is no restriction on the y value, so there is, so y basically is anything. Y is an element of all real numbers. Okay, and then part E asks to, so part E says, if 102 is a point on the base graph, state the coordinates of the transformed point on gx. Okay, so I have 102 as my point. I'm just going to do it on my table of values that's already been indicated. So I have 102. It's not working. 102. And figure out what my transform point is going to be. So 100 divided by 2 is 50, minus 1 is 49. And 2 times -1 is -2, minus 5 is a -7. So my transform point is going to be 49 and -7. And that's it for example number 2. Thank you.